Hi everyone, this is practice formative of chapter 3, question number 16. In this question, we need to determine the area bounded by the curve, the horizontal line, and the y-axis. So since we are looking for the area that is shaded towards the y-axis, therefore to find the area, we shall use the integration towards the y, the dy. So the boundary y1, y2, so the boundary will be on the y-axis. Therefore, the subject has to be x, which x is written in the y. Okay, so therefore for question A, our lower boundary is 1. The upper boundary will be the y-intercept of the straight line, which is 5. Okay, because y equals to mx plus c. And then we have to make x the subject, so 2x equals to 5 minus y, x will equals to 5 minus y divided by 2. So we shall integrate from 1 to 5 of our x towards the y-axis. So 5 over 2 minus y over 2. So let's integrate this part. We have 5 over 2y minus y squared divided by the 2 and then times with the new power 2. And then we substitute the upper boundary and the lower boundary. Okay, so 5 times 5 divided by 2 minus 5 squared, which is 25 over 4. Okay, this is the upper boundary, then minus the same expression, but substitute the lower boundary. So we have 5 over 2 times 1 minus 1 over 2 times 2, 4. Okay, so let's find the lowest common multiple. Times 2 on both numerator and denominator. So now we have the lowest common multiple 4. So up there we will have 50 minus 25. And at the same time over here, also the same thing, we multiply 2 on both numerator and denominator. So we will have 10 minus 1 over 4. Okay, so we have 25 over 4 minus 9 over 4. So we can combine it. 16 over 4 divided by 4, the answer is 4 units squared. Okay, so that's it if we were to use the integration to find. Alternatively, based on this shape, it is actually a right angled triangle. We can use the formula of finding the area of triangle, half times the base times the height. So the base here, we got to find a corresponding x value when y equals to 1. So when y equals to 1, we have x equals to 5 minus 1 divided by 2. So we have 2. So the x coordinates here is 2, which means the base is 2. And the height is 5 minus 1, 4. Therefore, half times the base times the height. So we got 4 units squared. We got the same answer. Unless the questions say we have to use the calculus method. Otherwise, we can opt for the formula to find the area of the triangle. Okay, now let's move on to part B. Okay, let's look at B. So for B, the shaded region is on the left side of the y-axis. And therefore, we will get the area which is in the negative value. It is just like if the area is shaded towards the x-axis. So above the x-axis is positive, below the x-axis is negative. So if we are shaded towards the y-axis, on the right side of the y-axis is positive, on the left side of the y-axis will be negative. So in this case, to find the area, we have to put the modulus so that our area will always be positive. So we have to integrate. The lower boundary is y equals to -2. The upper boundary is when it passes through the origin, so the y coordinates is 0. And since it is towards the y-axis, our subject must be written in x. Okay, must be written in x. So x is the subject. So this one bring over you get minus 4. So y plus 2 squared minus 4. Let's expand this part. We will have y squared plus 2 times y times 2. We have 4y, and then plus 4, then minus 4. And therefore, we have y squared plus 4y. So let's put this one in our integration. So y squared plus 4y. And next we integrate it, y cubed over 3 plus 2y squared. And then we substitute the boundaries into the expression. So when we substitute the 0, so 0 over 3 is 0, plus 2 times 0 is still 0. So the first part is 0, and then we minus the second part by substituting negative 2 into the expression. So negative 2 cubed is negative 8 over 3, and then plus negative 2, when we square it, we got 4, so we times 2, 8. And next, 0 minus, let's find the lowest common multiple, that is 3. So we times 3 up and down. So we have negative 8. We have negative 8 plus 24 divided by 3. And we will, don't forget the modulus, we will get positive 16, okay? 16 over 3. And then 0 minus 16 over 3, we have negative 16 over 3 and modulus it. So we can change it to a positive 5 and 1 over 3 units squared. So that's it for the area for this shaded region in B. Okay, next, let us move on to part C. So the shaded region is on the right side, so we can just integrate directly. So for part C, we shall integrate, the area is equivalent to the integration from -1 to 1 of the function that is written in y squared. So make x the subject, so it's y squared plus 3. So y squared plus 3. Let's integrate it. We have y cubed over 3 plus 3y. And then let's put in -1 and 1. So we have 1 over 3 plus 3, and then minus -1 over 3 minus 3. So over here we have 3 and 1/3 minus the -3 and 1/3, therefore plus 3 and 1/3. So all in all, we have 6 and 2/3 area square unit. That's it. We found the answer for part C. Now, let's move on to part D. For part D, we have the shaded region on the left side and the shaded region on the right side, even though they are connected, but we have to split them into 2 parts when we do the integration, because the one on the left side of the y-axis would be negative in value. Only the one on the right side is positive, so we have to split them. So area of the shaded region, this is D. We got to integrate, all right, this part from -1 to 0, okay, of the curve with respect to the y, all right? Make sure the x is the subject, so we are integrating 2y cubed minus y squared minus 6y. And we have to plus into the integration from 0 to 1, must put the modulus because this area is on the left side of the y-axis. So same thing, 2y cubed minus y squared minus 6y with respect to y. Okay, so let's do this part. We have 2y to the power of 4 over 4 minus y cubed over 3 minus 6y squared over 2, and then -1, 0 plus the modulus. We can copy this, or you do it one more time just to make sure you do it right. So 2 y to the power of 4 over 4 minus increase the power by 1 divided by the new power, increase the power by 1 divided by the new power, and then we're going to integrate them from 0 to 1. Okay, now, so for this one, let's simplify this part first. So we have y to the power of 4 over 2 minus y cubed over 3 minus 3y squared. Okay, from -1, 0. So for this one, we will copy the expression that is already simplified right away. Okay. And then we got to integrate this part from 0 to 1. Now, over here, let's use the calculator to do the calculation for us. Okay, don't have to count one by one. Okay, therefore, for this, we shall key in the function, right? Key in the expression. So you can use y, or you can use x, up to you. So y to the power of 4. Okay, this whole thing raised up to the power of 4. So y raised up to the power of 4, close bracket, over 2, and then minus 1 over 3 times y cubed. Y cubed. Shift cube function, and then minus 3y squared. Okay, key in the function, key in the expression in the calculator. And so what is the y that we need to substitute in? Put in a 0, put in the upper boundary, that is 0. Okay, 0, and then minus the lower boundary part. Let's key in -1. We have -2 and 1/6. -2 and 1/6. I left this one. We have to show how we substitute in. All right, we have to show. Okay, cannot let them know we are using the calculator to do this. Okay, so we have -1s. -1 raised up to the power of 4 over 2 minus -1 raised up to the power of 3 over 3 minus 3 -1 squared. This is the first part. And then the second part will be 1 over 2 minus 1 over 3 minus 3. Then minus, when we put in 0, we got 0. Okay. And then over here, we plus. This one, since it's used, it is still in the same function, I mean, same expression. We just need to substitute the upper boundary, which is 1 here. Okay, key in 1. So we got -2 and 5 over 6. So -2 and 5 over 6 minus 0. And now we can calculate mentally over here. This is 2 and 1 over 6 plus the -2 and 5 over 6 after modulus become positive 2 and 5 over 6. Okay, 2 and 5 over 6. So add these two parts together, we have 4 and 6 over 6. So 4 and 6 over 6 is actually 4 plus 1. Therefore, the answer is 5. 5 unit squared. Okay, that's it for question number 16.